Hi, we're taking a look at previous problem, and if you notice I put three graphs of this. Oh, by the way, welcome to radio, KNOW, everything you want to know about calculus but was afraid to ask. And I'm taking a look, and I have this shape, and the shape is formed by the equation f of x equals, or y equals, the sine of x, that quantity squared, and y equals 1, or g of x equals 1. And I'm going to rotate these, and first one I'm going to rotate is this one right here, and I'm going to rotate it around the x-axis. And I'm going to rotate it here. And the next one I'm going to rotate, I guess I'm going to write the word rotate first, rotate about y equals 1. And over here I'm going to rotate about y equals 4. Alright, so over here, here's the x-axis, and this is what I'm taking a look, so I'm going to rotate it around here. And so if I notice, right in here I have a hole, and so I have a washer situation, and the washer situation is going to be pi times the integral from a to b of capital R squared minus lower r squared, and in this case dx. And so what I need is, I know a and b already, so I know that I'm going to have pi, and I'm going to integrate that from 0.615 to 2.526, and I need to identify what my r is, and I need to identify, or my capital R, by the way, and what my lowercase r is. And so I'm going to come over here, and I'm going to grab a different color and go red here. And my capital R is always my distance from my outer post region to the axis of revolution. So it's perpendicular right here. I'll draw the perpendicular line. So the question, what is this distance? Well, this distance is the top minus the bottom, and if you remember, the equation of this is y equals 0. So what I'm subtracting is the quantity sine x, that quantity squared, minus 0, or simply it's going to be the sine of x, that quantity squared. Now, my little r is the hole, the radius of the hole. So the radius of the hole is this distance right here. I'm going to call that little r. And if I take a look from 0.615 to 2.526, this r is exactly the same length. It doesn't vary. Where if I take a look at the red line, you know, my big R, it varies. Sometimes it could be a height like this. Alright? So what's that height? Well, this is 1, or 1 minus 0, so I'm going to have my little radius be 1. So what I have here is the sine of the quantity squared that function squared minus 1 squared dx. Now, this could be the sine of x, that quantity of the fourth power. But if you recall, I put them in my calculator, so I'm going to come to my calculator here. Here they are. If I take a look, I'll exit back. There they are in y1, y2. I do not know why there's a 3 here. Oh, I do know why there's a 3. Because that's the equation of this graph, so I got to go back here. And you guys probably saw that back on the previous one, that the equation right here, let me slide this over, there's a 3 right here. So there's a 3 here, and there's a 3 here. So I'm going to have to go back to my previous video, I guess. So let me go to my calculator, and that's what I have right there. And so I'm going to go into I'm going to go into my menu, and I'm going to go back to my matrix right here, and I'm going to set it up. If you notice, I have this right here, and on a Casio I can just go up here and I can change some of these. Oops. Well, let's see if I can get through here. Get to where I want to be. There I go. I want to square my y2. That's my 1 squared. And I want to square that also. So right here, if I come to here, this is my y1, and this is my y2. And if I come back to my graph, you can see that when I go to my menu and I go to my graph, here's my y1, here's my y2. So I'll go to my menu, go to over here, and so I want to set up my integral like this. And so you'll want to do the same type of thing. And if you take a look, when I graph that, in this case right here, notice this is what I'm looking at. I'm going to get 8.427. This up here is a previous problem, so ignore that. So this is what I'm looking at right here, this value right here. I will do it one more time just to show you, because maybe I confused you. I'm going to go to math here, go to my integral. Again, I'm going to go to bars, go to my graph, grab my 1, and I'm going to have that squared minus my y2 squared, and then I'm going to oops, where are you going to go here? Oops, there I go. Alright, I want 0.615 to 2.526. So when I integrate that, there's that 8.427. Alright. Eight 0.427. Alright, so let's take a look at this one. Here I am rotating about y equals 1. So I'm rotating it here. So what's going to happen is this graph right here, I'll try to draw it very slightly, is going to be reflected down here. That's supposed to be a reflection. And these, my radiuses, I'll put one right here, is going to be rotated around. So this is going to end up being right to here. And I'm going to do that. And so in here, let's see if I can put that in there. See what happens. In here, if I shade this right here, this is going to be kind of greenish in here. So it's going to be solid. I'm not going to have any open spaces, so I don't need to have R. I just need to know this distance right here. This right here is going to be my radius. And so what I have here is I have a disk. I don't have a washer, and it's going to look like this from pi from A to B of r squared dx. So what is r in this case? Well, r is going to be the top curve, 3 times sine of x, that quantity squared, minus 1, the difference between those two. Okay, from this spot to this spot right here. And so my pi now, my actual calculation that I'm going to put in is going to be 0.615 to 2.526, and it's going to be 3 times the sine of x, that quantity squared, minus 1. Now this whole thing in here, squared dx. Alright, so let me show you how I'm going to do that on my calculator. I'm going to come here, and again I'm going to go to exit. I'm going to go to exit again. I'm going to go to math. I'm going to grab my antiderivative, and then I'm going to go to bars and grab my y. Oops, I'm going to delete here. I'm going to have, if I slide this over a little bit, I want to set it up correctly, I'm going to have parentheses, and I'm going to have my y1 minus my y2. Remember, this right here is my y1, this is my y2, and I'm squaring that difference. And I'm going from, for an upper bound, I'm having 2.526, and I'm having a lower bound of 0.615. And now when I calculate that, I get 3.688. So I'm going to write that down. 3.688. Alrighty, so those are my values. Now this next one is y equals 4. Well, y equals 4 is up here. So I'm revolving about this. So again, my r, you notice there's a hole here. So my little r, let's use blue, is going to be this distance, let me find a spot here I haven't used here, right here, from the axis of revolution to the closest part of my region. That's my r. And my big R is going to be from the axis of revolution down to the farthest region, right there. Now notice, that distance never changes. It's always 3 minus 1. It is a distance of 2. So I can say that my capital R is equal to 2. My lowercase r is going to be 3 minus 3 times the sine of x, that quantity squared. Right? So now I'm going to set up the integral. And I'm going to have pi. And I'm going to integrate. I just thought of something. I'm hoping I'm having pi on all my problems. Otherwise I got to redo them. And I'm thinking I forgot that. 0.615 to 2.526 of 2 squared minus, okay, I'm going to have these brackets, 3 minus 3 times the sine of x squared, that dx. Alrighty, let's see what those are, and let's just see what I've been doing on here. Yeah, if you notice right here, I didn't multiply by pi. So on this one, it's pretty easy. I'm just going to hit times, and I'm going to go pi down here, shift pi. And so this answer really is 11.586. So I'm going to come back here and I'm going to fix that. Cross that out. I'm sure you guys knew that, 11.586. Coming back to this one, and I'm going to redo this one over here because I got a feeling that's wrong. My guess is I did not multiply, and if I look at this, let's see if I can scroll this up. Maybe I can. Yep, right here where I had 8 point, this right here. See if I can get that all the way and get you to refigure that. Let's try this again. Right back there, let's press that. Oh, it's not giving me that. So let me come back up here. It's 8.427, so I'm going to do 8.427, and I'm going to multiply it by pi, and I get, let me delete here, I'm having issues, sorry, you guys deserve better than this, I apologize. Let me try this again. Let's go to math, let me integrate, let me put in, I'm doing this particular one right here, so I'm going to go to my vars, I'm going to go to my graph, I'm going to get y1, and I am squaring it minus, Let's go to y2. I'm squaring that. And over here I have 2.526. And down here I have 0.615. I'm press execute, and now I'm going to hit times pi. And I could have the pi in front and done that also. So over here, this is wrong. Let me take a look at that again. It's 26.474. So 26.474. And now I'll come to this particular problem right here. And I'm going to go to my calculator again. And I'm going to exit, and I'm going to delete the screen. And I'm going to look at this right here. And I'm going to type in pi first. So, which is what I suggest that you do. And then I'm going to go to math, and I've got my integral. And I'm going to have, I have 2 squared minus parentheses 3 minus, and I'm going to go to bars, and go to my graph. I'm going to choose y1, and I'm going to square that. Again, I forgot to write that in that integral, so I better do that. I'm hoping you guys are seeing all these mistakes I'm making. And I'm going to go 2.526, and down here I'm going to have 0.615, and I have 18.191. Here I'm going to write this squared, and right here I'm going to slide this over here, 18.191. Alrighty, so those are my answers. Again, on the previous problem, when I had the video, I had done the work correctly. What I didn't do is write the functions correctly, and this really was 3 times the sine of x quantity squared. So hopefully, if you watch the first video, you'll see the second one, and hopefully I'll have a chance to amend it or make a new video shortly. Alrighty? That is the end for radio KNOW.